In this video, I'm going to show you how to do everything that we have done in Unit 3 by hand in Stata. Now, I know it seems like the initial thought is, well, hey, if we can do this in Stata all along, why haven't we been doing so? But my general philosophy is that until you've actually done it by hand, you really don't understand what you're doing. By putting stuff into Stata, you're very likely to get a right answer. However, if anything does go wrong, you may not know how to fix it, or it's a lot less likely that you'll have the tools to be able to fix the problem if something does go wrong. So in general, I say that doing things by hand is our initiation, and that's how it is. So I'm going to be using two different things. I'm going to be using the data set from the datasets folder. It's the ages of the presidents of the United States. And I'm also going to be using the week 7 learning quiz. So I'm going to be redoing those items in Stata. So the first thing is that when you open this data set, the data editor doesn't show up. The reason for this is that you don't need to see the raw data in order for Stata to be able to do its thing. So it doesn't show up initially, but if you open up the data editor, it'll be right here. I kind of like to take a look at it. So these are the ages of presidents when they were inaugurated. So these are the inauguration ages. And so I'm going to window that down. And so then, like I said, we're also going to be using the learning quiz from week 7. So I already have those solutions open. If you'd like, you can open them from the solutions folder and follow along. Actually, I already have this open down here. So there was two parts of Unit 3. The first part was all of that normal distribution stuff that we needed to eventually get to confidence intervals. So in order to do this in Stata, we need two different commands. So the confidence interval stuff I'm going to skip on the week 7 learning quiz. I'm going to cover that with the second half of today's Stata programming. So there are two commands that you need. These are going to go in the command box. And this command is display normal. So what it's going to do is it's display normal gives you the area to the left of a specified z-score. So for this first question, you would have found your z-score. That's important to be able to do. Some programs enable you to be able to just type in the mean and standard deviation instead of finding the z-score, and you can probably do that in Stata with a special downloaded package. But for now, we're just going to be using it for this capability. So notice the probability that it gives you is 0.3974. In the learning quiz, we actually had to do 1 minus this probability. So you have two options. The first option is to just do 1 minus manually by hand, which is what I would have done since I'd already done this command in Stata. Your second option, however, is to actually just put the 1 minus right in the command line. Either one is completely up to you. When you are doing the learning, the lab activity for the 5th lab activity, let's actually open that. You're going to be required to state your code line for Stata. So yes, you can do it the same way you did by hand, but you are going to have to use or at least state the Stata code line. So the goal of this assignment is to do everything that we've done in Stata, everything we've done in Unit 5 by hand in Stata. Now, the lab activities slow down once the project starts getting pretty active. We'll go over the project in another video, but the project documents are up and available for you to look at. They are pretty self-explanatory, but one thing I will be posting additionally are some sample posters so you can get an idea of what they should look like. So lab activity 5 won't be visible for you right now, but I guess I'm going to make it visible when I post this video. So back to the Stata and the learning quiz. So that's the first data command. That's one of two things that we're going to get today that we put in this command line. There's going to be a few other things throughout the course we put in the command line, but there's not going to be too much. So the second question says, what score would a student have to get to be in the top 5% of scores on the exam? And this is actual information from the firefighter exam in New York. So this mean in the standard deviation. So if I wanted to get this, what I need is a z-score. So I actually need to go backwards. And the command for this is going to be inverse, INV, but for short, inverse norm. So now what we want to know here is the z-score that has, so this is 5% to the right. And so now I'm going to put 0.95 to have it be to the left. Or if you accidentally put in 0.05 or you liked 0.05 and you wanted to put that in, you will end up getting the negative version of the z-score. I changed the wrong thing. Let's fix that. There we go. You'll get the negative version of the z-score, and then you can make it positive. So it's important to understand the two different commands. This is the same thing as when you're using the z-tables. You look on the outside in, or if you look on the inside out. So I call it wild goose chase when you're finding areas inside the z-table. So that's it. Those are the two commands that are going to take over the first part of Unit 3. So I'm going to close this out. Those are our two commands. That's it. You have one that finds an area, and you have another one that finds a z-score. So I would maybe kind of write your own notes down for these. So there's two different ways that you can go about confidence intervals in Stata. So we're actually going to look at two separate cases for both of these. So this is the Unit 3 practice questions. And so the first thing that I would recommend, no matter what you're doing, and this is why the Stata actually comes last, is that picking the Stata test 100% depends on being able to decide which type of test that you are even running. So I'm going to go through each of these using the summary statistics, and then I'm going to do a few of them with raw data. So to get to the confidence interval menu, you're going to go to Statistics, Summary Tables and Tests, and then Summary and Descriptive Statistics again, except for usually we go to this right here, but you have a whole menu available to you for confidence intervals. Honestly, whichever one you choose in here is up to you. So let's look at both of them. If you choose confidence intervals here, it's going to give you the ability to just check a box. So, okay, I'm finding a confidence interval for a mean on this one. So I'm assuming you've already done this question and we're redoing it. So the variable, we don't have a variable here. So this is the test you're going to select if you have the raw data. So looking here, sometimes you see, okay, there's no boxes for me to put in what I have. So this is the one you use if you have the data. We don't have the, well, we do have the raw data, but we also have the summary statistics. So to make our lives easier, we're just going to go to the normal mean confidence interval calculator. So there's two different types. There's a calculator, and then there's a comparison calculator, and we'll see the difference between those two. So this menu that pops up now gives you the option to type in your summary statistics. So I already had given this out when we did this in class, and then this was just extra practice for you online people. So the sample mean is 20.8. The sample standard deviation is 10.1, and the sample size is 15. The confidence level you type in manually. You need to make sure that you check the right box, and then you hit OK, and voila, there is our confidence interval. So I have decided that I want to type this in and do the raw data attempts. So I'm going to label variable 3 as, and this is real data. So these are, I'm going to call this ACC, short for arrests, charged, and cited. Um, so if you had the raw data in here, now, because the reason why I decided I wanted to use that other option is that I don't like the number of decimal places that I rounded to previously. And you don't want to round until the very end of the problem, typically, if you're doing something in a professional setting. So we would go to our confidence intervals, the generic one, and from here, you can just select your data. So this is really nice because it kind of takes some of the thinking out of it, and I'm not saying that that's what people want, but sometimes it is just nice to say, hey, here's my data, come up with a confidence interval. But what you want to pay attention to is that this mean here is different. So that's one good thing to check. Do I have a typo? I did type that in quite fast. All right, so I must have had a typo in my earlier one. That's actually a good thing to note. Um, so I'll have to make an adjustment on this earlier key here. I did this in my calculator earlier, and so it looks like I must have had a calculator error when I had done that. So that's good to know. And this is one reason why it is really nice to have technology, because when I entered these into my calculator, the screen didn't show the whole entire amount of the numbers. So I wasn't able to see all of the values at one time, which when I check myself here, that's kind of what I go through. So when you do the confidence interval option, you end up getting all this stuff here. This is not the standard deviation. So please be careful. This is the standard error. It's the standard deviation divided by the square root of the sample size, which hopefully sounds familiar. So I'll make a note. My confidence interval is off by a little bit, but this is the confidence interval that we would copy over here. And again, this should make sense. We shouldn't distrust data. It's just because I had put in the wrong numbers here. So for the second question, it is possible to have raw data for proportions. For this specific example, it's looking at whether or not people favor the death penalty. So I would say that they would be broken down into two answers. Yes, they favor, which is kind of a weird word. They favor the death penalty, or no, they do not. And so you would have 2001 of these that reflect this right here. However, I find for proportions that is not the best way to go about it. I think it makes things a lot more confusing. So what I would do here is go to the proportion calculator. So this is under that same exact menu. The calculator you're always going to use if you have the summary statistics. So my summary stats are 12,000 or 1,241 people out of 2001 preferred or favored the death penalty. So this is going to default to exact. I was just kind of playing around with this a little bit. But the confidence interval that we are finding using this formula is actually a walled confidence interval. For this first upcoming assignment, if you do have to find a confidence interval for a proportion, you will have to use walled. In the future, the hypothesis testing gives us a confidence interval spit out from its output, and we're just going to be using the confidence interval that is outputted from it. So I actually have down here, so I'm going to hit OK. Make sure that you remember to change this confidence level. In a previous version of this video, I did forget I had it at 95%, and I was going back and forth and trying to figure out what had gone wrong. But I actually displayed both of these outputs to show you the difference is very, very small. It's just slightly different versions of estimating this error. So some people use one, some people use the other, but they're very close, as you can see. So we are using the walled confidence interval, so you're going to have to check that walled box in order to get agreements. And see, even this one is off by just a teeny bit. And the reason for that is because we rounded our point estimate. So using technology does offer, it's bittersweet. It's good because we can deal with lots of data, but it's also a problem because if things go wrong, we do have more of I don't know, and something to overcome, because when you're looking at a box with a bunch of numbers in it, it's sometimes really difficult to figure out what exactly had gone wrong. So in this next question, we are estimating a standard deviation, and we already have our summary statistics. I feel good about this one, so and this is too much data to enter in right now. So I'm going to go for this. We still do have to check our assumptions. So at some point, you still either need to be given the Shapiro-Wilk p-value, or you would need to type in this data and check the assumption. But this is a confidence interval on a standard deviation. And so it automatically checks the box for you, which is nice. We have a sample size of 22, a sample standard deviation of 2.104, and we want a 95% confidence level. So the confidence interval that we get out is exactly the same. There's no, we rounded to enough decimal places here, is what has happened. So there's no disagreements at all for any reason. But this is one thing that you need to get used to, is that if you do something by hand and you round, like you did right here, and you're always rounding to 4 decimal places, it is possible that you're going to be off by this last decimal place. So the last question, actually, if you go to the mean calculator here, you don't get an option to put in a population standard deviation. So using the confidence interval calculator, we're not able to do this one. The reason is that this situation is a little bit uncommon. So for this to have happened, you I don't know, you really already have a lot of information about your population. Somewhere in here, when we do our hypothesis test, so I'm going to do a sneak peek. When we do our hypothesis test, we will be able to estimate that confidence interval. But for now, we don't need it. It's not a very common situation. So we're just going to leave this one off. So the last piece that I wanted to look at is when you have the data given to you. I'm going to get this one out of here. So when you have the data given to you, you are going to select a different menu. So there's 2 different options. You're going to do the calculator if you already have the descriptive statistics, and you're going to do the other confidence interval option if you have data. So when you click on confidence intervals, right, we want a mean here. The data that we're going for are going to be the age of our presidents of the United States when they were inaugurated, and then you just select which you're doing here, so our confidence level. So when you say yes, a 95% confidence interval for the age of the presidents of the United States when they were inaugurated is 52.6 to 56.9 years of age. So if you wanted to repeat this for the standard deviation, you would just end up selecting the different box. Oops, not that box. You would end up selecting a different box, double checking your variable, double checking your confidence level. And again, I would not use this for proportions. Proportions you should only use the calculator for. So the confidence interval for the standard deviation of the age of the presidents is 5.3 to 8.5 years of age. So standard deviation as regular people, we aren't really as concerned with it. But there we go. There's 2 different components to Unit 3. There was the normal distribution stuff, the confidence interval stuff, and this is everything that you need for these. If you have any questions at all, please feel free to send me an email. Don't forget that setting up a Skype appointment is an option for you. The reason that I like Skype is that I'm able to share my screen. So if you are requiring assistance for Stata, I can just do a screen share and then you can see what I'm doing as I'm doing it. Again, if you have any questions, feel free to send me an email.